Okay.
All right, I think it's recording. Okay, so yeah, hello, welcome. This is the CSI monthly community meeting, which is recorded. And oh, I see we have a few people. We have only one item on the agenda, which is to discuss the CSI spec change for QoS. I will just mention that there was a release about 2 weeks ago. I think that was the final release of the, was it the 1.4 CSI spec? Actually, I don't know what the new version number is, but that was for the current Kubernetes release. So that release is complete according to SOD. And I don't think there's anything else to discuss about that. Oh, wait, okay, I just found it. It looks like it's 1.8 was the latest release. I've forgotten how many increments we've had. All right. So if anyone else has any discussion topics, please add them to the agenda. But we'll start off with Sunny's topic.
So this is a spec change. If some of you already have the context, this is a new CSI API we propose to add for the QoS feature. The naming of it right now we decide is modify volume, but it will start with allowing only the QoS parameters like IOPS and throughput. So the use case of this is that if there is some changes around IOPS and throughput, we want to use this API to modify those parameters in the volume. And the difference between this API and the volume expansion API is that for the volume expansion, the spec requires the size requested has to be, the target size has to be larger than the existing one. But for IOPS and throughput, we will not have this restriction.
Yeah, so the I just saw the actual PR. So and this is in my email box and I hadn't clicked on it yet. So now I have more context. Thank you. And this is, so we're just going to discuss just the CSI spec aspect of this change, not the higher level bits, or do you want to discuss the higher level bits and to give more context?
So I think I'm more interested in the CSI spec of things. For example, right now we are just passing different parameters, and there were others suggesting should we use a map, that type of like discussion. I want to know what.
Yeah, I mean, so the thing that jumps out at me looking at this change is here we have IOPS and throughput as like first class fields in the RPC, whereas at creation time, currently these things would be set through the opaque parameters map, right?
Yes.
And so that disconnect I'm uncomfortable with. I feel like we need to be consistent at the CSI spec layer with how we treat this stuff. Like either it should always be opaque maps or it should always be first class fields for things that we want to give the first class treatment to. And so I guess my first question is like, did you think about just using an opaque map here and letting modify volume request arbitrary parameters to be modified? Like, is there a reason that you didn't propose that to begin with?
I'm personally just more used to some clearer parameters, but I'm also open to, as you mentioned, that if it's opaque in the like storage class, we should make this consistent with the behavior.
Yeah,
I haven't thought about that. So
there are definite downsides to having everything just be opaque, right? But in the case of these QoS parameters, like we've struggled in the past to like clearly define what they mean. And one of the benefits of just saying, well, it's an opaque string is we can say, well, what it means then is dependent on your CSI's plugin implementation, right? A CSI, one plugin vendor can specify that IOPS means one thing, and another vendor can specify that it means a different thing. And as long as it's just an opaque string, there's no problem, right? And so that has benefits and drawbacks. Like the benefit is it gets us out of the problem of figuring out what an IOP is. But then the downside is the user experience is still kind of muddled, or at least not consistent across all implementations. So yeah, the nice thing about capacity is everyone understands what a gigabyte is, right? There's no disagreement about that. I mean, there's the binary gigabyte and the decimal gigabyte, but we've specified everything's, in binary in Kubernetes. But IOPS, like there's legitimate differences, like is it a 4K IOP, is it an 8K IOP, do IOPS scale with volume size, or are they absolute? There's all sorts of subtle questions about exactly what do you mean when you say you get 1,000 IOPS. The other popular dichotomy is the some systems try to guarantee a minimum level of IOPS, where others just specify a maximum, rate limit, with no guarantee that you'll get that amount. And so I think we kind of have to figure out, like, do we want to get into that quagmire at the CSI spec layer of trying to tell people what we think an IOP is, and then putting it, because I don't think we can just put in the spec IOPS, and then not define what that is, because immediately people will come back and they'll say, well, my system IOPS are 128K, and but other systems are 4K, and so the numbers are going to be all wrong on my system. And it's like, well, yeah. So I kind of lean towards letting it continue to be opaque like it is at volume creation time, because it makes it simpler. But I recognize that there's definite drawbacks there, because then then it becomes impossible to have a consistent user experience at the CO layer above CSI, because all you have to say is, well, whatever the IOPS are, they're plugin dependent, right? Kubernetes can't tell you anything about what an IOP is, because CSI won't tell you what an IOP is. And so we have to just be silent on the subject. The other downside I see is the moment you put an opaque map in this volume modify volume request RPC, people are going to say, well, we can modify all kinds of things that aren't QoS related, right? And there certainly are things that you might want to be able to modify that aren't QoS related, and that might be a good thing. But then there's other things that you definitely can't stuff that you would set at create volume time that is immutable, and you just can't change it. And so then the question becomes, if you try to change it through the modify volume request, what do we do? And assuming that the answer is we just throw an error, then it's like, well, then how do you know which ones you can change, which ones you can't? Then we have to solve that problem. But my intuition is that's a better problem to solve than trying to have the CSI spec be prescriptive about what an IOP is. I mean, Xing, you've been around in the industry a long time. Do you have an opinion on like what we should be doing with IOPS at the CSI spec layer?
Yeah, I also thought this should be not, if it's opaque, is definitely, it's kind of hard to define the behavior, just as you said.
But that can be good, right? Because then we don't have to come to an agreement. We can just say a NetApp IOP is a NetApp IOP, and an EBS IOP is an EBS IOP, and if they don't have anything to do with each other, that's not our problem.
Well, yeah, and there's definitely pros and cons, right? So this is like completely like a black box. So in one hand, it's kind of consistent with the creation time. If it's a creation time, it's opaque. Then when you modify it, it's opaque, then kind of consistent. But yeah, but I think the consistency thing is one thing, right? In CSI drive, in the spec, we normally will define what is expected. If we completely saying we don't know, then it's
I feel like
write a spec, I guess.
I feel like the choice that we have before us is either find a way to define IOPS clearly enough that people can sort of squint at it and say like, yeah, that'll work for everybody, and then have consistency between create volume and modify volume, so that, you know, for QoS, like you specify it the same way at creation time and update time, or just bite the bullet and say this has to continue to be an opaque parameter like it was at creation time, and then figure out what to do about stuff that's not mutable.
Well, how can we even, if it's completely opaque, how do we even know what is mutable, what is not, right? If it's completely opaque, we don't really know.
But yeah, there's that problem, and then there's the problem of, like, for Kubernetes. I mean, this is not a CSI issue, but for Kubernetes as an example of a CO, there is the question of like, how do you reconcile these values, right? Because if somebody makes a change to the IOPS for a particular volume from like 500 to 1,000, and then the sidecar calls modify volume and the operation fails because something is down at that moment, it needs to retry, right? And so that means Kubernetes then has to be keeping track of the current IOPS and the desired IOPS somewhere in the Kubernetes layer. And we don't do that, right? So for the opaque parameters that get set at volume creation time, we don't save them anywhere. I don't think we do. And so like we would need to start saving all of them, and then having a reconcile loop that would compare the current values to the desired values and call modify volume request every time they don't match. And that's a more significant change in the Kubernetes. I mean, we'll have to do that even if it's just IOPS, right? We'll have to store current IOPS and desired IOPS so that we can reconcile them when they don't match.
But for creation, we do retries, right? Let's say the third class has opaque parameters that we can do retry. That should be fine.
Right. But the moment that create volume succeeds, all Kubernetes does is it writes down the name of the storage class that was
after
used,
that, right?
And then forgets about everything else.
That's true. Yeah.
So, I'm still inclined to say opaque parameters are going to give us less trouble, but it does mean that we have to solve these other problems of, you know, how are we going to reconcile the values of the Kubernetes layer? What are we going to do for irreconcilable or for immutable values? And I guess just write that down and say, okay, you know, the CO can send a request with a string map, and if the SP supports updating the values specified, it can succeed. But if not, like, you have to return some error, and then we have to figure out what that error means. Because like, I'm trying to think of a good example of something that you can't change dynamically, like say like whether the volume is encrypted or not, right? If someone says, I want an encrypted volume, and then later they call modify volume and says, don't encrypt it anymore. Like, I can't imagine any storage system that would say, okay, I'll just decrypt the volume, right? They're going to say, no, you can't change that. It's encrypted for its whole lifetime. And so like that request you would expect it to fail. And so then we have to specify, you know, well, what is the error, and how does Kubernetes know that it shouldn't keep retrying that request, and all that stuff.
If I can just comment, I mean, it's in a way, it's even, we know now it's even worse than that. For example, at Google, the PD Extreme disk SKU has provisioned IO at create time only, and the hyperdisk throughput SKU has dynamic IO. So like, even within the same provisioner, the same parameter, the semantics, you know, can change depending on the exact type of disk you have. So like, I mean, you know, and I think this means it's clear that it's certainly something that Kubernetes isn't going to be able to track. Like, so I wonder if we just have a general thing where we have a, the opaque map as a spec. The return from the CSI driver is an opaque map. That's the status. That's the current state. And I mean, I think ultimately it has to be the driver that decides if the spec and the current state are reconciled. So maybe we just need to make that explicit in the return from the CSI driver, and
so
that be like a kind of first class thing in the status.
So you're saying like you have 3 error responses. One is I have updated it and it's okay, or it was already updated, or 2, like I failed to update it, but you can retry because your update would have been valid, and 3, like I can't update what you asked for, and so stop retrying. All right, like those are the 3 cases.
Yeah, and I think the difference between the first and the third is that the third is an error case that the orchestrator Kubernetes should post as a error, and then the first one is not an error case. That's sort of everything is working.
Right. Yeah, that's the good case. It means it's okay. Stop reconciling because it now matches.
Yeah. And again, it isn't a guarantee that the spec matches the status, because it might not be possible, but it's something where the driver can decide that it's good enough and does not need to be retried.
Yeah, but then the problem you have, if the driver is the only thing that knows whether it matches or not, is what can it return to Kubernetes such that Kubernetes will know when the desired state has changed again, right? Because if someone, I don't know what the Kubernetes interface for this is supposed to look like, but like if someone comes in and tries to edit the IOPS again, like now you want to start reconciling again, but how does Kubernetes know that it needs to do that? Other than just like a general like state flag that says something changed, try to reconcile. That makes me very nervous because it feels racy just to have like a single flag that says something changed. Like you kind of want to know what the desired state is and what the actual state is so that you can just compare them.
Right. I mean, if we had a version ID, and then so we have a version in the spec, and then the status says which version this particular message is for, and then until
that's even more gross, because now we're polluting the RPC layer with information about object versions. I would almost prefer to have like some get volume operation or modify the existing get volume operation that says get me all of the mutable parameters and their current values, and then have modify and then have that persisted at the CO layer, and then have the CO be able to mutate those values, and so it knows that okay, these are the mutable values, these are their current values, these are their desired values, and they don't match. Therefore, I'm going to go ask the SP to go make a change.
Yeah.
But then then the SP could return back, okay, I've updated the values or I haven't updated the values. But then you would have some subset of all the mutable values stored somewhere. And
would that be still opaque, or they will be known by the CO at that time? It's like a key value.
I feel like it has to be opaque.
But it isn't completely opaque too, because the CO decides if things match or not. And like, I think that's something that makes me nervous, because the concept of matching might be provider dependent.
You're right.
So like, just like in particular, suppose that IO requests get rounded to the nearest K. Or then like, we might be good even though the current state doesn't exactly match the request.
Yes. Yes, that's messy.
Yeah.
And I can't think of a general way to solve that other than just some flag where the SP tells the CO like, you're good, you're reconciled at least now.
Right, but I think that has to have a version, right? Because as you
right,
pointed
well,
out,
yeah,
it's
if you want
racy
to
it's
make it
right?
not racy, but like that, I feel like that's going too far towards making it
Hmm.
complicated. Like there's got to be a different way to have a relatively simple API that can that where you can reconcile and get to the right answer without something that complicated. I mean, I agree. You could devise a versioning scheme down at the RPC layer and make this work, but like we don't have that level of complexity anywhere else in the CSI spec, and it doesn't feel
Yeah.
like this is a good place to add it.
Yeah, that's fair.
So,
That's fair.
So
Right now for volume expansion, it marks there is an operation in progress. And if there is an operation in progress, it doesn't try to update it.
but that's all at the CO layer. Right? At the SP layer, all that happens is you say expand the volume on the controller side, and it'll say either I did it or I didn't do it, and it returns back a Boolean that says you need to do additional work on the node. And if it says you need additional work on the node, then Kubernetes will try to do it on the node. And all of the rest of the state is at the Kubernetes layer, because Kubernetes understands what a gigabyte is, and it can it knows where it is in the process. And so like, yeah, to the point earlier, if the SP is going to like round the IOPS to a certain number, like you want that behavior to be sort of up at the, well, I'm trying to think. Like the way this would work with storage is like, if let's say your storage system rounds up to the next gigabyte, and someone asks for a 4.5 gig volume, and you give them a 5 gig volume, like that's explicitly okay, because the size request of a volume has a minimum and a maximum, and Kubernetes only ever sets the minimum. It doesn't set the maximum. So if you give it something bigger than what it asked for, like, Kubernetes is happy. In the case of IOPS, like, you could have a min IOPS and a max IOPS and say, as long as it meets that. But then we're adding semantic value that Kubernetes has to understand that, this is a number, it's going to be in a range. It has to, be greater than or less than this value. It starts to force Kubernetes to really understand what these opaque parameters mean in a way that I kind of don't want to do, because like I said, if we get into that territory, then we're going to have to argue about, what is an IOP exactly, and write it down in the spec. And someone will come and say, no, that's not what an IOP is, on my system. And you'll never win that. You'll never win that fight, I don't think.
Hey, Ben, so I was just looking at the cap itself, right? It actually has some examples. Those are not opaque, as I'm seeing. But I didn't read the whole updated cap yet, but I was just looking at the example that shows the number. I mean, can that be not opaque? Can we define just concrete numbers? So that, what is the problem of doing that? At least I see that in the example. So,
well, you're saying like let's at the Kubernetes layer say there is a thing called an IOP. It is a number.
Can we look at the examples in the cap?
Can you send me a link to the cap? I don't have it at my fingertips.
Yeah. So I'll put it in here.
Thank you.
So if we can just define those as numbers, it'll be much easier.
Well, but is what you're saying, like at the Kubernetes layer, just say IOPS is a thing that has a numerical value, and we're not going to tell you what those numbers map to, but you can control it, by setting a floor or a cap, and then as long as the system can get above that floor or below that cap, we're happy. So something like
So
that.
we can, yeah, so we can define that. So do you want to show that in the
Oh, well,
share the screen? So
is that visible?
yes, it is
Okay.
visible. I think there's an example of the proposal section. Where is the example? Yeah, yeah, if you look at here, right, there are some numbers here. So if we define them as numbers, so we can just, but we need to decide, does this mean like a maximum or what? Or minimum, right? So we need to decide that one. If we can decide that, would this be, you know, at least
It gets us closer, but like I'm still very nervous about, so I know that for some systems they really want IOPS to scale with size, right?
Right. So I was thinking that would be like another parameter. So like this would be one C would be like a maximum, right? So maybe we could have maximum, minimum, and then you know, per GB or something. But we could have all of those. Each one is different. Each one works differently. We can't just have one that fits all, right?
Well, hold on.
Yeah.
Go ahead.
Oh yeah, I was just saying, because so like a very specific use case we have here is a disk queue where the IOPS are billed as a separate thing. So it's an independent knob from capacity, and people are actually billed. And so it's different if you specify, 300 or 350. It isn't a cap, like the amount you pay changes. So I think it is important to have some mechanism that can capture that. So it isn't just a cap.
Well, but what
minimum.
about, so like going back to the systems where the IOPS and the space scale together, one thing you can do is say, like, if someone comes in and says, I want a 10 gig volume with 1,000 IOPS, you can say, well, I can't give you, in order to give you 1,000 IOPS, I have to give you a 3 terabyte volume. And so I will just give you a 3 terabyte volume, so you get your 1,000 IOPS. And the fact that it's bigger than the size you wanted doesn't matter, because you're paying the same either way, right? You're just wasting space.
So
And
for that particular use case, can we just use volume resize? Then it's automatically will get that.
Well, but what I was getting to is if you're in that world where like the system is going to give you the whatever volume meets both your IOPS and your space constraints, then a request to modify the IOPS becomes an expand volume under the covers, right? Like now if I say, okay, I actually want 2,000 IOPS, the system might say, okay, well, I'm just going to expand the volume to 6 terabytes under the covers so that you get your IOPS, but like you didn't ask for the volume to be resized, but the system just had to do that to give you your IOPS, and it makes it
does it mean if I request this amount of storage and then like I want this amount of IOPS, I can also access more of the storage that I requested for?
Well, it depends, right? Like so the way CSI plugins work usually is you underneath the covers you get some block device, and then someone puts a file system on top of that block device, and then you use the file system. So what you can do is you can like make the block device way bigger and then have a smaller file system in it, or you can just let the file system be this whatever the block device size is. And similarly, when you resize, if you have a 3 terabyte volume with the file system on it, and you ask for more IOPS, and what the system actually does is expands the block device from 3 terabytes to 6 terabytes, you don't have to expand the file system, right? You can just keep using your 3 terabyte file system in the 6 terabyte volume, leave the space on the table. It would work. But then if you wanted, but you're paying for the 6 terabytes. So if you want this space, you could go through the expand volume process and let it, do the resize FS and give you your full 6 terabytes. But like, again, like how you trigger those different things, from the Kubernetes layer, it's not going to call the resize workflow unless it thinks the volume needs to get bigger.
Can you treat them as different capabilities? Right. So one capability would be, you just set this IOPS, whatever minimum or maximum to decide that, and then another capability would be you set this IOPS that's grow with your volume size.
Well,
Those are different capabilities, right?
I know, but I kind of like the idea of just having them as like 3 separate knobs and then letting the storage system figure out what it wants to do. Like if the storage system can deliver capacity and IOPS independently, like let it do that. If a storage system needs to tie them together for whatever reason, like, you know, it's always okay to give someone more space than they asked for or more IOPS than they asked for, usually.
Right, but I mean,
and so you could just do it and say from the CSI layer, like all we're promising is you have at least as much space as you asked for and at least as much IOPS as you asked for, and we're not, you know, and you might get more, right? Because that's already the situation today, is you might get more space than you asked for. So this would just create a bunch of new situations where you might get more space than you asked for.
are you saying you prefer just to have like one opaque option, like driver do whatever they can do? What is your suggestion?
Yeah, well, and crucially, report back what you actually did. Or
So-
I take that back. I take that back. Well, what I mean is, we need to make it possible so that the billing can line up, so that, like, you know, that whoever is running the billing system needs to be able to see the capacity number and see the IOPS number and know what the billing rules are, so that you can generate the right dollar amount for what that user should pay, right? The CSI plugin actually doesn't need to be directly involved, as long as the billing system knows what the CSI plugin is doing. This Kubernetes doesn't care, right? Kubernetes just said, hey, I know what I know what the minimum volume size was, and I know what the IOPS that I asked for was, and the CSI plugin met the request. And so somebody is going to bill that user for something, and the formula will depend on both of those numbers. But again, that's opaque to Kubernetes, as long as those numbers are available.
Right, but the outcome will be two different, right? So basically so you give one input, it could be anything. It could be a separate just IOPS change, or it could be your volume as part of it also get expanded. So I'm just saying, like, if you just think about it, like the user does not know what to expect. Suddenly,
but if
together with IOPS, I mean, what is expected behavior? Even if we want to write this in the CSI spec, right? You could get this or both. Well, I was wondering if it's better we can add two separate capabilities.
I think you would need your front end to explain to users, like, you know, if you ask for more space, this is how much you're going to pay. If you ask for more IOPS, this is how much you're going to pay. And by the way, like, an increase in capacity will give you more IOPS, and an increase in IOPS will give you more capacity. If that's how the system works, right? You can just have that be there up front, and then say, you know, that your bill will reflect how much you asked for. And you don't have to use all your IOPS, you don't have to use all your capacity, but we're going to bill you on the whatever's more expensive.
And also, I don't know how that would interact with the volume expansion. The volume expansion itself is pretty complicated already.
Well, no, but that's the beauty, is Kubernetes does all the complicated things, and all the billing system needs to know is, what is the volume size now, right? That's all it cares about.
Yeah, but then what
So
kind
so you could have this, you could have the same scheme with IOPS, right? As long as you say, what is the IOPS now?
So let's say in Kubernetes, let's say we have this API, okay, and then this would be I don't even know how that would look like. It's some opaque map that is I don't know.
I want to get back to the CSI spec portion of this, instead of going off, you know, dealing with all the problems that exist at the Kubernetes layer. If we want to be able to have, like, clean reconciliation, you know, and have Kubernetes store the current value and know what the desired value is and be able to update those values, I think we at least have to go as far as saying it's not really opaque, that there is something called an IOP, and it has a numerical value, and you have to go at least that far. And maybe the throughput number is similar. You know, there's a throughput number that's a megabytes per second. You'd have to figure out if you want to treat read and write separately or combined. There's just some details, but, like, you could say, you know, these are numbers, and Kubernetes is going to reconcile them.
I think the previous meeting we were discussing, these are independent read-write parameters, both for throughput and IOPS.
Sure. I mean, we can just declare that, but like someone will come along and say like, well, write IOPS are way more expensive than read IOPS on my system, and I'd rather bill for them separately, and then we have to deal with that. Like I prefer simplicity too, not adding the kitchen sink in if we can avoid it. But we have to figure that there could already be systems where those opaque parameters contain really, really detailed information about like read IOPS and write IOPS and read throughput and write throughput and whatnot. And those systems won't be able to evolve into this new model, assuming we implement it the way we're talking about, if we just have a single throughput number and a single IOPS number. So we just have to, cope with that.
Do you want to leave room for future expansion? Like we have this, let's say it's a rewrite, but then in the future maybe we will add read only, then we will add the IOPS per GB in the future, that maybe could be different parameters we want to add gradually.
Yeah, I think that'll end up being even more messy if we implement a new RPC and then we change the RPC after it exists. It's very easy in CSI to like add whole new RPCs with new messages, but like modifying an existing one gets complicated because you can't in a backwards compatible way add non-optional parameters. So like if we can get the RPC right, it'll buy us a lot. And the sort of the most general RPC is the one that just sends a string map down and says, figure this out, and then tell me, if you're reconciled or not, right? Because then you have sort of infinite feature expandability, but then that pushes the challenge back up to the Kubernetes layer to decide whether you're done reconciling or not, because Kubernetes won't know which of the parameters are immutable and which ones are mutable, and whether there's any funny rounding behaviors and all that stuff. So,
but Kubernetes level, I mean, are you saying we're not following the example in the CAP? Is because if we look at the example in the CAP, we actually have those numbers defined, right?
I mean, Kubernetes could, well.
So if we have this way, this is pretty clear, then CO will know how to reconcile, just look at that number, right? Whether it's
right. Yeah. Okay. So assuming that this is the design of the Kubernetes layer, then yes, the opaque map will not work. We would need to have at creation time, we pass down these numbers, and we have a modify volume that passes down numbers, and it prevents us from, then if you in the future you really want to split out read IOPS and write IOPS as separate things, like you have to then change everything, right? You're just
but if you look at Ben, if you look at this the example below the storage class, right? So that's the proposal. It's basically you pass them in as the parameters here. So those are still under parameters.
But we would have to, so in order to reconcile it, Kubernetes would have to know which opaque parameter corresponds to IOPS and throughput, right? Like these would have to become magical strings that Kubernetes would know. And that we've done that before. It's not the end of the world. It's kind of gross to have magical strings in a opaque map, but it is doable.
I think those keys will have to be like defined, right?
Yeah.
So it's not, I mean, it's under parameters, but it's not really opaque.
Right. And we would need to
have to use the same. Every driver has to use the same key, basically.
We need to prefix this with like storage.k8s.io / provisioned IOPS on create, so that it's properly namespaced. But yes, like we could have a magic string that refers to creation IOPS, and another magic string that refers to throughput, and then we could store those values, because we currently don't, in the PV object, so that we can reconcile them when the user wants to change them. We can absolutely do all that. But then like if you ever want to distinguish between read IOPS and write IOPS, you have to go back and change everything, right? Like this one field then becomes 2 fields or 3 fields, and this becomes 3 fields, and so it would block us from ever really improving, it cheaply on this design, right? We would have to go back and do an expensive rework to improve it. Whereas if everything is just opaque strings, like it's way easier to iterate on that and to have individual vendors, do something fancier while others do something less fancy.
If it's completely opaque, then what would be like let's say in this coordinate in the PVC, what will the value be? It's just like another parameters on the request?
Yeah, if it
weird.
was completely opaque, then like you'd have to take all of the opaque parameters from the storage class and copy them to the PV, and then have a way of through the PVC, like saying I want to change one of those, or forcing people to modify the PV to affect the change, which is another way to do it. But yeah, and that's nasty, but it's very, very flexible. So we have to decide if we want to lean towards a really, really flexible design that's sort of future proofed, or if we want to do something simpler that is fairly rigid and brittle and it only solves this one slice of the use case
if you
space.
really allow like opaque parameters to be under, let's say, the request, then driver can implement it whatever they want, right? It can be even not IOPS. That's even possible. If what is the thing that a CO can tell, what it's doing. I mean, because
can you rephrase your question?
I was just trying to say, you are saying that I heard, maybe I misunderstood. I heard what you're saying is we would just have parameters and maps like under requests, and then basically just driver just tell you whether this is a reconcile or not reconcile, basically the modify.
Right. That would.
But
that
what
would
I'm
be
saying,
the,
what I'm
the
saying that
map way of doing
I guess, yeah. So of course the advantage, of course, that's it's easy to expand. You can do whatever you want. But then the downside would be you don't even know what they're doing. Maybe this is not even IOPS there on the parameters. We don't know what is defined there. It's completely.
So actually, can I? So it kind of seems to me we're dancing around like a fundamental question about if we're exposing a way for a provider to have parameters that Kubernetes reconciles versus are we like exposing new storage options? So like we have this specific question of how do we solve this problem when we have an update for parameters that may or may not need to be retried, which is like a pretty concrete problem. And then we also have this question of like if we have IOPS that may or may not depend on size, and we can give a fairly general way for people to specify these trade-offs, and then have different providers come up with different mechanisms for IO and size and like those things to be traded off. So like those seem to be like two pretty separate problems to solve. And I guess maybe before we dig too far, we need to decide which one we're actually trying to solve. Like, are we just talking about a way to add parameters from a provider, or are we talking about general IO and storage capabilities in Kubernetes?
I think that we're trying to constrain the problem to just QoS for now, right? Because the bigger problem is harder, and so we're trying to shrink the problem that we're solving. But I think we're feeling anxiety as we notice that if we do a very narrow solution to the narrow problem, like we might just come back tomorrow and realize that we want to do more, and we won't have done ourselves any favor by having a narrow solution. I think that's part of my anxiety, is that like yes, we could do this very narrow thing, and it would move the ball forward. But like tomorrow, someone's going to come up with a new thing that they want to mutate in exactly the same way, and we're going to have to do all of the work over again to enable that.
Yeah, so that I agree. I think that's why I'm starting to think that actually constraining this to QoS is making the problem harder. That actually the easier, more tightly scoped problem to solve is just this: provider has parameters that need to be specified and possibly retried. So this isn't a QoS specific thing. This is just a additional parameters problem. And how do you have a mechanism to change parameters on a provider via Kubernetes?
So I agree with that, but all of the discussions we've had at the SIG storage level in Kubernetes have been about the UI wanting to look like this, requests where it's definitely not opaque, right? We're trying to say that Kubernetes knows what a throughput is and knows what an IOP is.
Yeah.
And it's we trying to avoid having to be like a bag of strings that just gets set in like a storage class and then modified as a bag of strings. So I agree that like just a totally general, like here's a bunch of updatable values, I'd like to update them please, is actually a relatively simple API to write. You have to deal with the reconciliation issues, but like it would make it impossible then to do what we want to do with the Kubernetes layer if we go down that path. So
yeah, I mean, I agree, but like I guess we don't actually know what we want to do at the Kubernetes layer with any of this. So just to take a specific example, like a mechanism to specify IOPS that might involve creating a volume of a different size, like that kind of makes me nervous. I see that being like an incredible source of customer issues. As people
I didn't follow what you said there.
So
what was the thing that you said you don't like?
Oh, the suggestion that you had before, where if IO throughput and size are tied, then to have something where somebody specifies an IO throughput, and the result might be a volume of a bigger size in order to satisfy that. Like, I mean, I think it's a reasonable approach. I happen to like personally think that it could cause problems and I don't think we need to discuss that, but I think the point is that like it's gonna be really hard to reach consensus in that space.
Yeah. I mean, I know that different people think about this differently, and yeah, reaching like everyone agreeing that we should do it a certain way is probably out of reach, but like the laws of physics dictate that, a particular brick of hardware has a certain amount of capacity and a certain amount of performance. And if you're trying to make any money, like you're going to sell that capacity and performance in such a way that like you're not leaving money on the table. Like that's just that's just an economic reality that hardware has limits, and people try to sell them in a way that makes sense. And so if someone comes up and says I don't need that much space, but I need a ton of performance, like you're going to end up giving them a lot more space than they asked for. And similarly, if someone needs a ton of capacity and not a lot of performance, you probably give them a lot more performance than they asked for, unless you can find like the perfect match, right? Like if you can host the guy that wants a lot of performance and no space on the same device as the guy that wants a lot of space and no performance, like then you have a perfect world. But like usually you can't do that. General storage schedulers sort of just have to carve up their available resources, automatically, and it's usually, I mean, you see this with machine types in the cloud, right? Like you buy your CPU and memory basically in bricks, and sometimes you can get like a high mem flavor and a high CPU flavor that gives you double the ratio, but like you're still stuck with the ratio. And if you want more RAM, you're stuck with more CPUs. If you want more CPUs, you're stuck with more RAM, because like at the end of the day, like the service provider is selling you a fraction of a box that has a certain ratio, and they have to make it fit. So the same thing happens at the storage layer inevitably. And we don't want to force everyone to think that way, but we have to recognize that a lot of people do think that way, and we have to just
Yeah, but I mean,
accommodate
I think even within those physical constraints, there's like such a wide range for what people could do that I just have a hard time seeing how that insight could translate to like something actionable at the CSI spec level.
Well, I think what you can do is you can just say like, look, these are my requirements. Like I want at least 10 terabytes and at least 1,000 IOPS, and you figure out what that means. Storage system. Give me either more performance or more capacity than I asked for, as long as you meet the minimum. And then, as long as the billing system sees those same inputs and can run the right algorithm to generate the cost, like it's not Kubernetes problem anymore, right? The CSI spec, the CSI plugin is doing the right thing to provide what the user asked for, and the billing system is charging them the right amount for what they asked for, and you can solve the problem outside of Kubernetes.
Well, yeah, I mean, except that like how different systems bill may change quite a bit, and like I mean, it kind of seems to me the result of that approach is like wild inconsistency in how deployments run based on where they are, which is already an existing problem, but I don't like that seems to make it worse, just because it increases the level of like opaqueness and magic.
I don't think that you can avoid this even today. I'm sure that there are systems today where the performance you get scales with the amount of capacity you ask for, and even though IOPS is completely opaque to Kubernetes today, some salesperson somewhere will tell you, if you want more IOPS, just ask for a bigger volume and you'll get more IOPS, and that's just how you do it, right?
So like that is again, speaking specifically from Google, like that is how you do it currently, and there are new disk SKUs coming out where those knobs are basically independent.
Yeah.
And so there are other constraints and stuff, but like I guess that I don't see how it's going to be effective to like unify all this stuff at the Kubernetes layer. Like it's always going to be a year or two behind what is offered. The exact semantics are going to drift.
The CSI spec though has to support all kinds of systems where that are way less smart about things like performance, right? Like there's tons of software-defined storage systems that can deliver you a gigabyte of capacity, but they have no idea how much performance you're going to get, and so they're just going to have to sort of wave their hands and say, you're going to get something. no promises.
Yeah, I guess that for me, all those observations point towards like, this problem of opaque parameters may be the best way to address it.
You're leaning back towards, maybe we just have a bag of strings, and Kubernetes copies it from the storage class to the PVC. We create a mechanism in Kubernetes to mutate the bag of strings, and then have a mechanism at the CSI layer to reconcile it in such a way that you don't keep retrying things that won't succeed.
Exactly. Yeah.
I mean, if we can solve that problem in a way that's acceptable to the Kubernetes community, I think then the CSI spec gets really easy, right? It's just modify volume, takes a map of strings and returns maybe a map of strings, maybe a status, and we're very careful about the error codes, but we could figure it out. And then all the problems are pushed up to the Kubernetes layer to say, well, how are you going to actually do that reconciliation, and where are you going to store all those copies of those string parameters?
Yeah, exactly.
So Sunny, you've been kind of quiet. What are you thinking? Because we're at the
just trying to like just digest what you said. That's it.
Okay. I mean, I can respond back to the CSI spec proposal as it is and say like, well, if we're going to do this, use passing down integers and modify volume requests, we could. There's some changes I would recommend, but like, but yeah, my inclination is similar to Matt's, and to say, you know, maybe at the CSI spec layer, we want to continue treating these things as opaque strings, so that, you know, we can have one CSI spec change that will support all of the things we want to do in the future, and then figure out of the Kubernetes layer like what we actually do.
Sorry, time check.
Yeah, we're out of time. I have another meeting, so I got to stop. I have the feeling that we'll continue talking about this. I don't know if anyone took notes. I apologize that I was not writing notes. I'll try to write some down after the meeting, in as time allows. And I'll send you the recording, Shing.
Okay.
All right. I better
Yeah.
stop the recording. Thank you, everyone.
Cool. Thank you. This has been a great conversation. I super appreciate all the feedback and thought.
All right.
Cool. Bye.